In this episode, you will learn how to make a moving character. Hello, and welcome to how to create a survivor's clone in Godot 4.0. My name's Brano, and this is going to be the first episode of a step-by-step tutorial on how to create a survivor's clone. So if you haven't done it already, you can go into the Godot website and download Godot. This tutorial is going to be in Godot 4, so if Godot 3.5 is still the latest version, you can just go into the download repositories. When it brings me there, go into 4.0 and download the latest build of Godot. It's pretty simple, it should just be in a zip file. Now, when you go there, you should be able to open up the Godot free beta.exe or Godot 4, and you should be able to create a new project, but we're not going to be creating a new project with this. Instead, what we're going to be doing is importing a project. So I have a link in the video description to a GitHub repository of the survivor's clone base. This is just going to contain a file structure with some images, audios, and sprites. So click on the link, go into code, and then click on download zip. After that, we'll go into our downloads. We will extract all. And then we'll just go into the survivor's clone. I'm just going to copy this entire file. And then I'm just going to be going into my projects folder, which I have in my Godot alpha. And I'm just going to paste it there. Afterwards, we're going to go back into our projects, and I'm going to click on scan. So we're just going to go up into wherever our folder was. I have mine in a folder called games and utility. We're going to be clicking on Godot alpha projects, and then I'm just going to be clicking on survivor's clone. I'm going to click on select this folder, and we should have a new game called Survivor's Clone. As always, if you wanted to create a new project, you can just click on the new project and it will create a new project for you. But now that we have our Survivor's Clone in the list, we're going to click on it and we're going to open the project template. So it just had to unload a bunch of things, and I'll just show you what we have so far. We have a couple of audio files in a .wav format. We have a MP3 file in a .mp3 format. This is just for music. We have a bunch of sound effects. We have a font, and then we have a bunch of various textures, which we're going to use as the episodes go on. So the way Godot works is that it has a node structure, which think of it just as containers, and those containers have specific attributes on them. At the moment, we're in a 3D scene, but to begin our tutorial, what we're going to be doing is adding a 2D scene. Now, this adds a node called node 2D, and what this is, it's just a place within a 2D space. So you've got various different attributes towards it, which we're not going to worry about at the moment. All we're going to do is do a right click and click on rename. You can also use F2 if you want. And we're just going to name this world. And then, as this is a node, and it's a container, you can add new nodes to it, and you can add various nodes types. There are a lot of different nodes, and it's very easy to be overwhelmed. I would just focus on learning the nodes that you need to know and ignoring everything else. So what we're going to be doing is, instead of going through this big list and trying to find a sprite, we're just going to be typing in sprite. And we are going to be using a sprite 2D. So we're going to be clicking on create. And we now have a sprite 2D node, which we are then able to go into textures. I'm just going to close the enemy. And I'm just going to make a background. So this is going to be a sprite with a background. I'm going to call this sprite background, which can be done with a double click. And then what we can see is that we have a fairly, like, just one tile of a sprite. Now, if we want to spread this out, we can, but that kind of stretches the texture and it looks really bad. So instead, what we're going to do is we're going to be using something called a region. And to use the region, all we need to do is click on enable region. It will disappear, but that's because we don't have really a rectangle. And what this does is we're able to select like a region for our sprite. So if you click on edit region and drag and drop, it'll kind of spread out. Now, it's kind of messed up at the moment visually, but what we're able to do is, and I forget exactly where it is, yes, texture. We're able to change some attributes of this texture. So at the moment, the repeat is set to inherit, but if we were to able to set this to enable, it's going to repeat the texture. You'll also see that this texture is a bit blurry, so we can also set this to nearest. You can set it to linear. You can set this to nearest mid map, and there's a couple of different options. But with inherit, what you may find is that the default, so inherit is just inheriting the project settings. And if you want to ever change that, you can go into your project settings, go to texture, and change the project settings so that the default texture filter is linear. Now, I think it should be nearest because I don't want my sprites to be blurry, but I'm also going to leave the repeat texture as disabled, and this is just going to be the default. Now, I'm going to be honest with you, as a background being really sharp, I think it does take away from the game. So I'm going to change this background and set this to not nearest, but linear. And I think this does actually make better. Now, if I want to make this really big in a deterministic way, I can just set the X and Y coordinates as well as the W and the height coordinates, which is I guess their way of just saying negative X, negative Y, positive X, positive Y. We can just type in, like, let's just do negative 4,000, negative 4,000, 4,000, and 4,000. And you get and by using the scroll mouse wheel, you can scroll out and you'll get a very, very big texture. And this is just what we're going to be using for our game. Now, I'm going to do a Control S. You can also do a scene and save scene. And we're going to Control S and we're going to save our world scene, which is a 2D node with a background sprite as a child. I'm going to create a new folder by right-clicking and clicking on New Folder, and I'm just going to call this folder World, and we're just going to save our world within that world folder. Pretty simple. Now, we should probably add a character to this, so I'm going to click on Add New Child, and what I'm going to do is I'm going to add a character body 2D. Which is effectively just a character that runs on code. So I'm going to rename this to player, and instead of editing stuff within the character body 2D, I'm going to make this character its own scene. And what creating this does is it makes the character really its own specific types of nodes with its own children. So I'm going to click on Save Branch as Scene. And I'm also just going to create a new folder called Player. So I'm going to click on that, Player, and to go into the player, we're just going to click on Open in Editor. Now what this does is it means that any change I make within the player scene is going to be apparent here. So let's add a sprite, 2D, and let's add the player sprite, 2D. Now there's 2 frames of animation, and I only want there to be 1, so I'm going to increase the horizontal frames, so I only get one sprite for my player. Now if I save this, you'll see that the player now has a sprite associated with it. Now if you wanted to play a scene, you can click on Run Project. It needs to load a particular scene for the initial side, so we're going to select Current when we're on World. If you are currently on the player, you can just go onto Select and make sure that World is selected. So we're going to click on that, Open, and you'll find that we have a very large scene and our player is in the top corner doing nothing. Now, this is a bit big for us, and we want this to be a pixel styled of game. So what we're going to be doing is we're going to go into Window. I'm going to turn on Advanced Settings, and I'm going to be changing the viewport width to 640 by 360. And we're going to be setting the stretch mode to canvas item. I'll just show you what happens when we don't do that. So when we play this, we'll see that we have, once again, a very zoomed in game. However, when we do the stretch mode canvas item, we still have the same thing, but when we do window width override, and let's just make it double, so 128 by 720, which is double, you'll see that it's a lot more reasonable and zoomed in to what you would be playing. Now, we don't have a movement script for our player, so we need to add our code. Now, the best way to do this is to click on the player, click on Attach a new or existing script. So we're just going to be adding the player and clicking on Create. This is going to have a bunch of code immediately, but yeah, we're going to get rid of all of it and create our own movement system. So before we do this, I'm just going to set the motion mode to grounded. So because this is going to be a top-down view, what we want this kinematic body to understand is that it's going to be floating. Grounded just means it's expecting there to be a floor, that it falls into gravity. Think of like Super Mario Brothers, where you fall down to the bottom of the screen when you jump. Since we're not jumping and it's bird's eye, we want this to be floating. So I'm just going to do a Control S there. And I'm going to start typing up our movement script. So I'm going to be making a variable called movement speed. And this is going to be equaling 40.0. We don't need to declare its type. You can if you want, but there's a lot of interpretation that happens within GDScript, and it's a fairly easy language to use because of that. Now, we need to have our game loop, and Godot has 2 primarily game loops. We got process, so we've got function process delta, which is every single frame, and then we've got physics process, delta, which is every single physics frame. So every single physics frame is defaulted to one every 60th of a second, and this is what delta will primarily be, 1/60th of a second. And within this physics frame, we want to detect how our player moves. So I'm just going to create a new function called movement. So the physics process is a Godot defined function, and the movement function is going to be our own personal function. You'll learn sort of what the Godot defined functions are as time goes on, but for the moment, we're just going to be focusing on our movement. So the way we're going to be doing this is by detecting what movement keys are being pressed. And before we do anything, we have to create our movement controls. So by doing this, we're going to go into project settings, go into the input map, and we're going to add a new action. We're going to add an action called up. I'm going to press the enter key to add, down, left, and right. And these actions need to have keys assigned to them. So I'm going to click on add event, and I am going to do it by, I believe it's filter by event, and I'm going to click on W, the physical key. And we want to make sure that physical key code is pressed because people can have keyboards with different letter variations on them. And we want the W key for most keyboards to be used. So click on OK, and now W will correspond to the up action. I'm going to then use down as S, A for left, and D for right. Now we just click on close, that's all good. So in our movement function, which is going to be processed every 60th of a frame, we're going to create a variable, and we're going to have this called xmov. And we're going to make this equal to an input. And input is just a way of Godot saying something happened, the player did something. So in our input, we're going to get the action strength. And this is going to be a 0 or a 1 value. So if I am pressing right, it is going to return a 1. If I am not pressing right, it is going to return a 0. And what I'm going to do is I'm going to do right subtracted by left. So input.get action strength. And we're going to be doing left. So pretty much if I hold down D, it's going to be 1 minus 0 if I'm not holding down A. If I'm holding down both A and D, it's going to be 1 minus 1. And this is just going to determine where we move. And then we're going to be doing the same for the y-axis, which is input dot get action strength. Now, the y input in Godot in a 2D space is the opposite of what you would expect. Up is actually a negative value, and down is a positive value. This can get a bit confusing. So we want down to be our positive value, and we want up to be our negative value. This is just something to keep in mind. I don't know why this was done, but it just is. And it's something that you just continually have to remember. So once we got that, we want to do another variable called mov. And mov is just short for movement. And we're going to make this a vector2, which is just a placement on a graph. So we're going to make that vector2 ymov. So the x value in the vector2 is going to be xmov. And the y value is going to be ymov. And then what we're going to be doing is we're going to be setting our player's velocity. And this velocity is just kind of where it's going to move. Where is the movement going to be directed to? So velocity equals mov dot normalized. We'll get into normalized with theory time, but just feel like it's there. And then we're going to multiply that by the movement speed. So if I have a vector of 40 x, 0, y, means that I'm going to be moving 40 pixels to the right every single frame. And then we're just going to be doing a move and slide. Now, move and slide already has delta associated with, oh, sorry, I did movement speed, sorry. Move and slide. So move and slide is a Godot function specifically for the character body 2D. And this is what causes our character to move. So now if I am to save this and run, I should have a moving character. We'll run through our code during theory time, but this is the end of the episode for how to make a moving character in a Survivors clone. The way our code works is that every 60th of a frame, we run the movement function. The movement function will check what action is being pressed down and assign a value of 1. In the case of x_mov, if right is being pressed and left is not, xmov is just 1 minus 0, ymov would be 0 minus 0. We would then put this into a vector2 variable that is pretty much just a direction. So in our case, this would be vector2 1x 0y. The first coordinate is x, the second is y. In order to move a character body 2D object, you need to set the velocity. So with the direction of right, which is vector2 1x 0y, we multiply that by the movement speed and we get vector2 40x 0y. After the velocity is set, we use the move and slide function to get Godot to know that we want our character to move. You may notice that there is a normalized function at the end of mov, so we will need to talk about that. You may also be thinking, well, if I'm setting the velocity to vector2 40x 0y, why isn't going 40 pixels a frame? The character is certainly not moving that quickly. We will talk about why in the next couple of topics. So you may have played a game in the past where moving diagonally was quicker than moving in a linear direction. This is because a vector of 1x, 1y is further away than a vector of 1x, 0y. You can prove this with Pythagoras' theorem to see why this speed up occurs. So what normalization does is it takes each vector and divides it by the largest side of a right angled triangle. So when we move with vector2 40x, 40y, we are actually moving with a speed of 56x, 56y. But vector2 40x, 40y dot normalized will act more like vector2 28.28x, 28.28y. And that vector speed causes us to move with a speed of 40. So unless you really want your diagonal movement to be roughly 40% quicker than linear movement, just use the normalize function and the math is done for you. Delta is 1 second divided by the frame rate. The reason it is used is because if your game goes from 60 frames a second to 20 frames a second, it's going to slow down the game. If you don't want your game to slow down, you can multiply your movement with delta. Delta is going to equal 0.05 with 20 frames per second and 0.0167 at 60 frames per second. If you need to travel for 600 pixels at 6 pixels per frame, it is going to take 1.67 seconds at 60 FPS. At 20 FPS, this would take 5 seconds. But what if we were to travel at 360 pixels times delta frames per second? This would be 1.67 seconds at 60 FPS and it would be 1.67 seconds at 20 FPS. The speed of movement would be recalculated per frame so that the game doesn't slow down. Move and Slide automatically uses delta within its calculations, so it's not needed in this specific tutorial. But if you're creating your own movement system, you will probably want to use delta. A node is an object with various unique properties to its type. It can be a parent, it can be a child. Using myself as an example, let's say that I am a character body 2D node. I have a couple of sprites of clothes that are connected to me and follow me around because they are my children and they are very attached to me. If I save myself as a scene, I'm now able to make multiple versions of myself, or I can place myself in new scenes. For example, I'm currently in my apartment, now I'm at the club. If I wanted to remove an item of clothing, I could just delete the sprite and it's gone. Perhaps I want to keep wearing a shirt, and if that's the case, maybe I'll just change the sprite. It's connected to me, so it's easy to change. That's pretty much the node system in a nutshell.